Hello, my name is Macy Hill, and today we're doing Lab 4 of my Chemistry Lab 2 class, and today we're doing reaction order and rate laws. So I drew a big black X on well D3, and the next step says to add 6 drops of distilled water into well C2 and D2. Okay, so this is C2. Add 6 drops. And D2. And now it says to add 8 drops of distilled water into well C3 and D3. So this is well C3 and this is well D3. So 8 drops. And 8 drops into this. Alright, and that's it for now. So the next step says to add 12 drops of hydrochloric acid to wells C1 and D1. So this is C1 and this is D1. So we'll add 12 drops. And now on D1. Alright, and then it says to add 6 drops of hydrochloric acid to wells C2 and D2. 6 drops hydrochloric acid. And 6 drops to D2. Alright, and now I'll add 4 drops of hydrochloric acid to wells C3 and D3. Alright. Now it says to carefully add 8 drops of sodium thiosulfate into each of the following wells of the 24 well plate: A1, A2, A3, B1, B2, and B3. So, these are A1 to A3, and these are B1 to B3. So, let's open the sodium thiosulfate. And we'll add 8 drops into each of these 6 wells. Alright, and let's check out the next step. So this is what it should look like now. Alright, so now I'll use a permanent marker to label these. So I've flipped the 24 wheels around, and now we'll, I've labeled one of the pipettes as Na2, SO2, and O3. So now it says to slightly tip the 24 well forward so that the drops of rows A and B that contain Na2SO4 S2O3 pulled together along the bottom rim. And it says suck up the contents of one of these wells into the Na2S2O3 pipette. So make sure to get all of it out. So I've gone out from A1 some Na2SO2O3. And the next step says to alright, so we set the C1 back over the X like this. And it says to take a pipette of N2S2O3 on the other hand, squeeze all the contacts of the bulb in this well C1 and immediately begin timing. So I will record the data into data table 1 and show you guys what happens. So I have put all the Na2S2O3 into the C1 well, and I've waited the seconds until the big X finally disappeared, and I've set a timer to see how much time it took till the X disappeared. So I will show y'all the results for trial 1 for C1 and D1 wells, and it's taken 25 seconds for the big black X to disappear. So I've repeated the steps for D1, and I've recorded when the big black X had disappeared, and also for trial 2 reaction time for C1 and D1 is both taking them 25 seconds for the black X to disappear. So I've done the steps for the C2 and the D2 wells, and they took a little bit longer. So here are the results. So it's taken 37 seconds instead of 25 seconds for the black X to disappear. So, and now I'll do the steps for C3 and D3 and show y'all the results. So for part 1 of exercise 1, I have taken the average reaction times of all the reaction times I've been giving, and the average reaction time of C1 and D1 is 25 seconds. The average reaction time of C2 and D2 is 37 seconds, and the average reaction time of C3 and D3 is 50 seconds. In order to get the average reaction time, the inverse of the average reaction time, we need to do 1 divided by whatever average reaction time we have been given. So 1 divided by 25 is 0.04 seconds to the negative 1 power. 1 divided by 37 seconds, it equals to 0.27 seconds to the negative 1 power, and 1 divided by 50 seconds is 0.02 seconds to the negative 1 power. So, and now we'll move on to part 2 of this experiment, varying the concentrations of 0.30 of Na2S2O3. So using this, we will carefully add 6 drops of distilled water to wells C5 and D5. So this is C5 and D5. So we will add 6 drops of distilled water to wells C5 and D5. So we have our distilled water right here. So 6 drops. And then 6 drops over here. And next it says add 8 drops of distilled water in the wells C6 and D6. So these two, C6, D6. So 8 drops of distilled water. Alright, and let's see what's next. Yeah. So it says add 12 drops of the Na2S2O3 to wells C4 and D4. So these two is wells C4 and D4. we'll need to add 12 drops of Na2S2O3. So this one right here. So 12 drops. Alright, and next it says to add 6 drops of the Na2S2O3 to wells C5 and D5. So C5 and D5. So let's add 6 drops of this. Alright. Now it says add 4 drops of the Na2S2O3 to wells C6 and D6. So we will be using this again. 4 drops. Okay. And then we carefully add, so it should look like this in the end. It says to carefully add 8 drops of hydrochloric acid into each of the following wells. So we'll do the last 3 rows of A and the last 3 rows of B. So hydrochloric acid, and we'll add 8 drops. Alright, and it will look like this. And next it says to use a permanent marker to make the label of the pipette hydrochloric acid or HCl. So I will be labeling this marker and now we'll move on. So I've labeled a new pipette. This is my hydrochloric acid pipette. I've made a new data table called Data Table 2 for this next part of the experiment. And now I will, so let's see what we need to do for this next experiment. So I will slightly tip this and then take this HCl out and put it into the HCl pipette. And I guess we're going to do what we did with the last few experiments and place all this HCl inside C4, D4, C5, D5, and then C6 and D6 and put it on our data table to check the average reaction time. And so let's get started. So I've timed this until the black X disappeared once again. So for the C4 and the D4 wells, they both took 20 seconds, and I've taken the average reaction time and the inverse of the average reaction time, which ended up being 0.05 seconds to the -1 power. And now I'll do C5 and D5 wells and determine their average reaction times and the inverse of their average reaction times. So I've waited till the X had disappeared for C5 and D5 wells. And here's the results. It has taken 45 seconds for both C5 and D5 to disappear. And the average reaction time is 45 seconds. And I've taken the inverse of the average reaction time, which is 1 divided by 45 is 0.022 seconds to the -1 power. So now we'll do C6 and C6 and D6 and see how much time it takes for the black X to disappear. So once again, I've waited till the X had disappeared, and it is taken for C6 and D6. It is taken 60 seconds or a minute for the X to disappear. and the average reaction time is 60 seconds for both of them. And I've taken the inverse of the average reaction time, which is 1 divided by 60, and it equals 0.017 seconds to the -1 power. And now for the final part experiment, I will take the reaction concentration of all these and show y'all the results of what I got for the math. Here are my results for the concentrations. And here's how I got them. And that is it for the reaction rates lab, and I'll see you guys next week. Goodbye.